So this is our video for J21, which is all about simplifying rational expressions, which basically means we're going to be reducing fractions, right? Remember, whenever we reduce fractions, all we're doing is canceling common factors that we have on top and bottom, because that represents a form of 1. So in other words, if we were going to reduce something like 4/8, right? We all know this equals 1/2, but the reason that it equals 1/2 is because 4/8 is the same thing as 4/4 times 2, right? I could write 8 in a factored version, right? So basically the first thing we do is factor so that we can see if we have a form of 1. So a form of 1 is any number over itself, right? If I have any number over itself, that equals 1. And so these I'm able to reduce and just be left with a 1. So that's how I'm getting 1/2. So we want to apply this same idea to rational expressions in that we first factor them, and then if we have common factors on top and bottom, we can then reduce it. So forms of 1 can look a lot of different ways. It might be just regular numbers like we had here. It could be something like 4/4. Okay, it could be variables. Maybe we have like m/m, right? Any type of number or quantity over itself. It could be something like 2xyz to the 4th over 2xyz to the 4th. Okay, as long as it matches on top and bottom, any of these constitute a form of 1. Okay, even if it's a quantity over itself. So that's what we're going to be looking for, okay? So that's one thing we're going to do in this section is simplify. And our strategy for simplifying is that we're just going to completely factor the top, completely factor the bottom, and then we'll reduce any common factors we have on top and bottom, okay? The other thing we're going to do in this section that's going to help lay a good foundation for moving forward and doing more with rational expressions, functions, and equations is understanding the domain. Domain is any possible x that could be plugged into this expression, okay? And normally we don't have a whole lot of problems. We can plug in all different types of x's from negative infinity, you know, all the negative numbers, 0, all the positive numbers out to positive infinity. But every now and then we have issues. So the issues we have to worry about when we're dealing with a fraction or a rational expression is that there are some numbers that make the denominator 0. Okay, the denominator or the bottom of a fraction, the bottom of a rational expression cannot equal 0. Okay, so we're just going to say the denominator cannot equal 0. So when we're trying to figure out what all possible numbers can we use, we're just going to think we can use all possible numbers except the ones that make the denominator 0. So I'm going to show you how to use the denominator to figure out what those excluded values should be so that we can find the domain, and then we'll get into simplifying by factor and reducing, okay? So let's look at some examples. So this first one says, find the domain of each rational expression and then simplify it, okay? So remember, for a domain, that means that the denominator cannot equal 0 because we're dealing with rational expressions. So I'm going to start with that. I'm going to start with looking at our domain. And our domain, we're going to focus on the denominator because the only domain issue we would have is if the denominator equals 0. So I'm going to go ahead and say that means that x squared minus 2x minus 3 cannot equal 0. I don't want that to equal 0, right? Because then we have issues. So I need to figure out what values of x cause that to be 0. And the way that we do that is just to factor and solve this. Okay, since it is a 3-term polynomial, I'm going to go ahead and do the sum product chart. My sum is my middle coefficient, which in this case is a -2. And my product, remember, is my first coefficient times my last. So my first coefficient here, if there's nothing written there, it's an implied 1, right? So I do my 1 times my last coefficient, which is -3. So I need a product of -3 that combines to -2. And actually the pairing that works is the pairing we used, right? We're going to use a -3 and a +1. Or in other words, a -3 and a +1, right? So what we did when we did our factoring section is once we find our pair, we use those to replace the middle term, right? But I shared with you a shortcut. The shortcut is that anytime our leading coefficient is a 1, the numbers that are in our sum product chart, the numbers that we found that we would normally replace the middle term with, those numbers are going to be the numbers in our factored quantities, meaning this will factor into x minus 3 times x plus 1. Okay. Now remember, we can only do the shortcut when the leading coefficient is a 1. So if this was like a 2, a 3, a negative something, okay, then I wouldn't be able to use the shortcut. But since my leading coefficient is a 1, then I'm going to go ahead and use the shortcut here. If you forget about the shortcut, you can always take these two numbers, replace the middle term, and then do grouping, and you'll end up with the same answer. Okay. All right, so now I have it fully factored. I don't want it to equal 0, which means I don't want either factor to equal 0. So x minus 3, we don't want it to be 0, and x plus 1, we don't want it to equal 0. And then I just solve each of these. So if I add 3 to both sides, that means x can't be 0. And if I subtract 1 on the second one, then that means that x can't be negative 1. All right, so now we know the two values that x can't be. So for an exam, I would be fine with you just saying x can't be negative 1 or 3. Okay, I'm not sure, depending on the problem, my math lab sometimes will just allow you to put in the restricted values. It'll say x can't be, and then you put in negative 1 and 3. Or sometimes it will have you write the whole entire domain in interval notation. It'll have you enter the whole domain in interval notation. Okay, so that means from negative infinity, as far back as we can go in the negative direction, right, up to whatever value we're taking out, and then from that value over to whatever the next value is we're taking out, to for however many values, right? So in other words, I'm going to show you this on a number line just so it makes a little bit of sense. If we had a number line, and this is all the way back to negative infinity, and this is all the way to positive infinity, right now we're saying x could be anything. It could be anything from negative infinity to positive infinity. But we know that x can't be negative 1 and it can't be 3. So wherever negative 1 is, basically we got to take that out. Some of you may have learned graphing with an open circle means where it's not included, right? So negative 1 is not included and positive 3 is not included. But it could be anything on this side of negative 1, right? It could be anything between negative 1 and 3, or it could be anything bigger than 3, right? So if I want to write interval notation to represent this, that means x could be anything from negative infinity to negative 1, or, in the way we write or with math symbols, is our union symbol. So negative infinity to negative 1, or negative 1 to 3, any of those numbers, or any numbers larger than 3. And so this is how we express our domain. So this is what we call our restricted values, and this is our actual domain. So on the problem, it might just say find the restricted values, which are the values you exclude from your domain, or they may say state the domain in interval notation. So I just wanted to make sure I showed you both ways of representing basically the same thing. Okay. All right, so we found our domain. The bottom can't be 0. We know that negative 1 and 3 makes it 0, so we are taking those out of our domain. Check. Okay, now the second thing was to simplify the rational expression. And we know to simplify it, we have to factor top and bottom. Okay, so I'm going to start with x squared minus 9 over x squared minus 2x minus 3. And as badly as we may want to do it, we cannot reduce right here. We can't reduce an x squared and an x squared and a 9 and a 3, because right now this whole thing is its own quantity. It's stuck together like glue with that minus sign. Okay, same thing on the bottom. This whole thing is a quantity. I cannot reduce a piece of a quantity or a piece of a factor. Okay, the only way I can reduce is if I have factors being multiplied together, not plus and minuses, factors being multiplied. So I want to go ahead and see what I can do with this guy. So I'm going to start with the top. I look at the top. First thing I look for is a greatest common factor. And here I don't have one, right? Because x squared and -9 have nothing in common. But I do have two terms. So remember, when I'm looking for two terms, my factoring method is to look for a difference of squares or a sum or difference of cubes. And in this case, this is actually a difference of squares. It's a difference because I'm subtracting, and these are both perfect squares, right? Because the base of x squared that I would have to square, right, would be an x, right? And the base of 9 that I would have to square is a 3. So remember, our little formula from the other day said if we had a squared minus b squared, that factors into a plus b times a minus b, right? So what we have found is that basically this is our a and this is our b. We found our first base and our second base. So we're going to go ahead and say this is a difference of squares and go ahead and rewrite this. So we know a difference of squares factors into the first base plus the second base times the first base minus the second base. So I'm going to rewrite this as x plus 3 times x minus 3. So now the top is fully factored. Now I want to look at the denominator. So the denominator, lucky for us, we already factored, right? We already factored whenever we were finding the domain. So I'm just going to take the factored version and write it here. We don't have to rework the whole thing. Let's not reinvent the wheel, okay? And then we go ahead and reduce whatever we can reduce. So here it would be our common factor is x minus 3. So what we're left with is x plus 3 over x plus 1. Okay. Now notice these two quantities on top and bottom do not match. So I cannot reduce them, and I cannot reduce pieces of factors, meaning I cannot reduce the x's because it's stuck like glue with this 3 and this x is stuck like glue with this 1. So I can't reduce that. But since there's nothing being multiplied on the outside of these, I can go ahead and write this without the parentheses. So this would just be x plus 3 on top, x plus 1 on bottom. Okay? So I want to do two more examples. Same idea. First, find the domain by figuring out what makes the denominator 0 and excluding it. Whatever we get, x can't be that. We exclude it from our domain. Once we've found our domain, then we can factor top and bottom to simplify the rational expression. Okay, so let me do a couple more and then I'll have y'all try some. So on this one, I'm going to go ahead and find the domain first. Remember, the domain we get from the denominator because we don't want the denominator to be 0. So 12x squared minus 12 cannot be 0. Okay, so this one, I always look for a greatest common factor first. Actually, this one could be solved by using that new square root method we just learned. But I'm going to go ahead and solve it by factoring because I know in order to simplify this, I'm going to have to factor top and bottom. So if I do the factoring now, it saves me a step later. So I'm going to go ahead and find my greatest common factor, which in this case is 12. And that leaves me with x squared minus 1. Okay. And then I need to see if this will factor further, which it should be able to factor further, right? Because I notice it's two terms, so I'm looking for a sum or difference of cubes or a difference of squares. In this case, it's squares, right? My base being squared here is an x. My base being squared here is a 1. And difference of squares, as we saw in the last problem, is always the first base plus the second base times the first base minus the second base. So this one's going to factor into x plus 1 times x minus 1. Okay. Now that I have it all set up, I can go ahead and set each of these equal to 0. Okay. Now the 12 doesn't have an x, right? This is not something that's going to change. It has no variable, so its value is not going to vary. 12 is never going to equal 0. So I don't have to worry about setting 12 equal to 0 because it doesn't have a variable. But I am going to set each of these equal to 0. So x plus 1 can't be 0. X minus 1 can't be 0. and then I just solve each piece. So this means x can't be -1 and x can't be +1. Okay. So again, if they just give you x can't equal and then, you know, like a box to put your answer in, we would just type in -1 and 1. Okay. But if they want to write it out in interval notation, what that tells me is that x can be anything from -infinity up to whatever my first excluded value is, which in this case is -1. Okay. And then from that first excluded value over to my next excluded value, so -1 to +1, or anything bigger than that other excluded value. Okay, and if it helps, you can draw the little number line, right, with -1 and 1, and figure out what the intervals are in between and on either side of them. Okay. All right, so we have our domain. Now we want to go ahead and factor so that we can reduce. Factor. Okay, so we have 9x squared plus 6x minus 3 all over 12x squared minus 12. Okay, so the bottom we already did over here, so I'll put that in here in just a second, but let's go ahead and work on the top. The first thing that I noticed with the top is that we have a greatest common factor, right? There's something in common with all three terms, which is a 3. So I'm going to go ahead and take out the 3, and that leaves me with 3x squared plus 2x minus 1, right? And then to further factor this, and I'm going to go ahead and put a little star here so I don't forget my 3. To further factor this, I have 3 terms, so I'm going to use sum product chart. So my sum is going to be my middle coefficient, which is a 2, and my product is going to be my first coefficient times my last coefficient. So 3 times -1 is -3. I need to find something that multiplies to -3 that I can combine to get 2, which would be actually the 2 that I use, right? A +3 and a -1, or a 3 and a -1, okay? Now, notice here my leading coefficient is not a 1. So that means I have no shortcut on this one. Boo-hoo, sad day, right? So if I'm not able to use a shortcut, that means I need to take both of these numbers I found in my chart and use them to replace my middle term. Okay, so I have 3x squared. I'm replacing my 2x with these two numbers. So that's going to give me a +3x and a -1x. And then I have my constant term, which is a -1. Okay, and I should be able to factor this with grouping. So out of the first two, I can pull out a 3x, which leaves me with an x plus 1. Make sure you are left with 2 terms because you started with 2 terms. When we take 3x out of 3x, we're dividing it. And 3x divided by 3x is 1. Okay. And then out of the second pairing, I can factor out a -1, which leaves me with x plus 1. Okay. And then, just like we always like to see, these match, right? Our leftovers match. So now we can take that out as a common factor. Once we take that out as a common factor, I'm left with 3x minus 1 as my remaining factor. Okay. And then don't forget to put your greatest common factor back on. Okay. So let's go ahead and see what we have here now. So the top factored into the greatest common factor that we took out, 3, times the 2 factors that we got from this remaining part of the polynomial. So x plus 1 times 3x minus 1. Right? So we did all this work on the side here just to change the top part into its factored form. And then on bottom, we can use the factored form that we got when we were finding the domain. So we know this factors into 12 times x plus 1 times x minus 1. Okay. So now it's fully factored on top and bottom. All we have to do now is cancel common factors. So obviously we have the x plus 1s that will cancel. The other thing that maybe isn't so obvious is the numbers, right? These are not stuck like glue to anything because there's no plus or minuses. These are multiplied factors. So we can go ahead and reduce the 3. 3 goes into 12 4 times. So that means on top I'm left with 3x minus 1. On bottom I'm left with 4 times x minus 1. okay? And again, this is a whole unit. So we can't reduce like the -1 on top and bottom because that's stuck like glue to the x terms, okay? But I can drop the parentheses on the top since there's nothing being done outside the parentheses. So that gives me 3x minus 1 on top and 4 times the quantity x minus 1 on bottom. My math lab does not require you to multiply out the denominator, nor do I. In fact, I prefer it to stay in its factored version, okay? All right, let's look at one more. Starting off with domain. So starting off with domain, that means we're looking at the denominator to figure out where x squared plus x minus 6 equals 0. What x values would cause this to be 0? Since I have 3 terms, I'm going to start with my sum product chart. My sum is 1, which is my middle coefficient here, right? And if it helps you, you're welcome to write in 1s where there's not coefficients, okay? So middle coefficient is 1. Product is my first coefficient times my last coefficient. So 1 times -6 gives me -6. So I need a product of -6 and an addition or a summation of 1. So that would be not 1 and 6, right? We're going to have to use 3 and 2. And since we need to end up with a +1, that means our 2 needs to be negative, right? 3 and a -2, okay? All right, so now that we have our pairing, now we replace the middle term and do grouping unless the first term, the first leading coefficient is a 1, which it is here. So yay, we can use our shortcut. Again, shortcut states that whatever the numbers are in my sum product chart that I would have replaced my middle term with, those will be the numbers in my factored quantity. So that means that this will factor into x plus 3 times x minus 2. And that's what we don't want being 0, right? So that means x plus 3 can't be 0, nor can x minus 2 be 0. And when I solve these, that's going to mean that x can't be -3 and x can't be +2, okay? And again, I'm fine with this, but if they ask you to write out the actual domain, that means x can be anything from -infinity up to our first excluded value, which would be -3. Then it can be anything from our first excluded value to our next excluded value, so -3 to 2, and then anything beyond 2. Okay? All right, so we're good with our domain. Now we just need to factor this guy. Factor. So on top, we have 2 minus x, and on bottom, I'm going to go ahead and bring over our x plus 3 times x minus 2, okay? So the bottom's already factored because we did that when we found the domain, so all we need to look at is our top piece. And our top piece has 2 terms. When there's 2 terms, we always look for a greatest common factor, which there's not really one, right? And we look for sum and difference of cubes or difference of squares. In this case, this is just an x to the first power. So I can't factor this any further. It is what it is, and there's nothing I can do about it, okay? But what I notice is that these 2 terms right here are almost the same, right? They're so close. I want to cancel them so bad, but I can't mark them out as it is because if you notice, the difference in these 2 is that here my 2 is positive, here my 2 is negative, right? Here my x is negative, here my x is positive. So the only thing that's keeping me from being able to reduce and cancel these 2 quantities is that their signs are different. So remember, I can always alter the signs or change the signs without changing the value of the expression by taking out a -1, like a greatest common factor. So if I divide out a -1 out of both of these terms, that's going to change this to a -2 and then the x to a positive x. Okay? So now, even though it's not written in the same order, it still has the same value because we have -2's and positive x's. So now we can go ahead and reduce those two quantities, which leaves us with just -1 over the quantity x plus 3. We just leave it like that, okay? All right, so on the next page, there are 3 for you guys to try. I know these are a little bit longer problems, so please pause the video and work it, okay? I know I say pause the video, but if you don't pause the video, it just plays straight through and shows you all the answers. I really encourage you to pause the video. Try these by yourself before you continue on with the video, okay? If you get stuck, go ahead and play the video, or if you are able to work through all of them and want to check yourself, go ahead and unpause it and we'll go over them. All right, are you ready to look at number 1? All right, so number 1 was kind of an easy domain because it's already factored for you, right? So we know that our domain cannot be 0. So if I set this and say this cannot equal 0, then all I have to do is set each factor equal to 0. So that means x can't be 0 and x minus 1 can't be 0. So 0 is one of my excluded values, and when I move my 1 over, x equals 1 is also an excluded value. So I know that my math lab doesn't have you write this set notation, so don't worry about that. Basically, x can't be 0 or 1, and so when we write our interval notation, it should look like -infinity to 0, 0 to 1, and 1 to infinity. Okay, don't forget your little union symbols, okay? So our bottom of our rational expression is already factored for us. And then on top to factor, the only thing I can do here, because I don't have an x squared, is take out a 3. So if I take out a 3 as a greatest common factor, that leaves me with x minus 1, and then I'm able to reduce those. Okay. All right, so that's the first one. Let's look at the second one, see how you did. On the second one, we start with the domain. We want the denominator to not equal 0, okay? Because this is a 3-term polynomial, we're going to use the sum product chart. So our middle term is -4, so that's our sum, and our product is our leading coefficient times our constant term. So 1 times 4 is 4. So what can I use to multiply to 4 that combines to -4? Would be -2 and -2. And because our leading coefficient is a 1 here, we can use the shortcut. Hey. So that means that this polynomial is going to factor into, using the two numbers we got here, x minus 2 times x minus 2. So we don't want that to be 0. And since these are duplicates, you don't have to set each one equal to 0. Obviously, you're going to get the same number, so we're just going to solve it once. Okay? X minus 2 can't be 0, which means that x can't be 2. So again, you don't have to write all this set notation. We know that x can't be 2, and so all possible values for our domain would be from -infinity up to 2, not including 2, and then anything bigger than 2. Okay? All right, so we have found our domain, so now we want to move forward and factor on top and bottom. On top, we don't have a greatest common factor, but I see that both of these are perfect squares, and they're being subtracted. So the base of the x squared would be x, the base of the 4 would be 2, and since they're being subtracted, like I said, it's a difference of squares. Difference of squares always factors into the first base plus or minus the second, right? So first base plus second base, first base minus second base. And then the bottom, we had already factored over here, right? So once I put its factors in, we should be able to cancel an x minus 2 on top and bottom, which means our answer is x plus 2 over x minus 2. And we cannot reduce any further because these are stuck like glue to one another with those plus and minus signs. Okay. All right. And our third and final problem, the domain, we look at the denominator. Our denominator is x cubed minus 3x squared equals 0, or can't equal 0, right, in this case. And I look for a greatest common factor always. Greatest common factor is x squared here. When I take x squared out of each of these terms, I should be left with x minus 3. And now it's fully factored, right? I can't go any further with x minus 3, but I can go ahead and set each of these equal to 0. So x squared can't be 0, and x minus 3 can't be 0. When I solve this one, you can just think through it. I mean, if this number squared gives you 0, the only thing this number could be is 0. Or if it's easier for you to think of like getting rid of the square, maybe we take the square root of both sides, right? And the square root of 0 is still 0. So either way, x can't be 0, and when we solve this one, x can't be 3. So you don't need all this set notation. So that tells us that x cannot be 0 and x cannot be 3. Okay, so we write our interval notation. It would go from negative infinity to 0, 0 to 3, and then 3 to infinity. Okay, so the bottom we now have the factored version for. It factored into x squared times x minus 3. So I'm going to go ahead and put that over here. And then for the top, we actually don't have a factoring method yet for x to the third power, right? Unless we have 4 terms. So we can't use sum product chart unless it's an x squared. So I hope that there's something else we can do, which there is. Notice all 3 terms have an x. So if I take out that greatest common factor of an x, now I have a 3-term polynomial that is quadratic, meaning the highest power of x is 2. So now I can do the sum product chart factoring with what's in here. So my sum is going to be -6, and my product is my leading coefficient times my last, so 1 times 9 is 9. What I can multiply to get 9 that I can combine to get -6 would be -3 and 3. And again, because my leading coefficient here is a 1, I can use my shortcut. So that tells me that my factors on this are going to be x minus 3 and x minus 3. Okay. Now don't forget, we had taken out that greatest common factor. So there should still be an x here, and then put in your x minus 3's that we just got from factoring it. Okay. So now I can cancel my x minus 3's on top and bottom, just 1, right? Just 1, because the number over itself cancels. And then I can reduce by x, because I have 1 x on the top and 2 x's on the bottom. So I can cancel the 1 from the top with one of the ones from the bottom, and I'll be left with x minus 3 on top and just a single x on the bottom. Okay. All right, so that is the end of, what was this one? J21, which is simplify rational expressions. So you should now be able to complete that homework assignment. If you have any issues, please let me know. I'll be happy to help.